Okay. Quick recap of stuff we did in class last time. We were discussing the expenditure multiplier, or rather, we were discussing a number of different multipliers. Am I correct? Now, the very first multiplier that we discussed was called the government spending multiplier. Does anyone recall the formula for it? You have your notes handy that you can refer to. What is the government spending multiplier equal to? It's 1 divided by 1 minus the MPC, precisely. Correct? Now, what is the definition of this multiplier? How would you define this in words? What is that 1 divided by 1 minus MPC? Basically, the government spending multiplier is the change in aggregate demand that would result from a $1 increase in government spending. That's what the multiplier is that correct? If the government raised its spending by $1, we've learned that aggregate demand in the economy would increase by 1 divided by 1 minus the MPC. Now, if the MPC, for instance, if that took on the value 0.9, then of course this whole thing would be equal to 10. Is that correct? So a $1 increase in government spending would cause a $10 increase in aggregate demand. Now, how does that work? There's a direct effect and then there is an indirect effect, correct? So when G goes up, you have this direct effect on AD, and that's because G is a part of AD. This is the direct effect. But then you have an indirect effect that works through a change in consumption spending. Is that correct? That's the indirect effect, and what we've learned is that the indirect effect is much larger than the direct effect, at least theoretically, right? So if you have a multiplier of 10, then really this direct effect is only the $1 increase in government spending. The remaining $9 comes from an increase in consumption spending, making the total 10. This, of course, is with the MPC of 0.9. Right? Now, the next multiplier that we studied in class was the tax multiplier. And what's the tax multiplier equal to? The tax multiplier, you will recall, is equal to negative MPC divided by 1 minus the MPC. So notice that this is a negative number. It's a negative number, right? And what's the meaning of the tax multiplier? How would you define it in words? It's the change in aggregate demand that would result from a $1 increase in taxes. Now, why is the multiplier a negative number? That's because we know that when the government raises taxes by $1, this reduces our, that is households, disposable income. And with less disposable income, we reduce our consumption spending. Am I correct? So aggregate demand, therefore, reduces when the government raises taxes. Am I correct? So if the MPC, again, were equal to 0.9, what would this whole thing be equal to? This whole thing would be equal to -9. which is to say if the government raises taxes by $1, aggregate demand in the economy would fall by $9. Fall by $9 because the change is a negative change. A negative change is a decrease. Correct? Now, how does this work? Well, the mechanism is as follows. Taxes go up. That causes household disposable income to go down. And that, of course, causes consumption spending to go down. Consumption spending is a part of AD, so that causes AD to go down. That's how that works. Right? Now, one thing that you will notice is that the tax multiplier is a weaker multiplier than the government spending multiplier. And you can see this right away with the values that we have here. With an MPC of 0.9, the government spending multiplier is equal to 10. The tax multiplier, on the other hand, has an absolute value of 9. It's a weaker multiplier. So if the government wanted to, let's say, cause AD to rise by a certain amount, it would take a larger decrease in taxes to accomplish this than a certain increase in government spending. Do you follow me? Because the tax multiplier is a weaker multiplier. To get the same effect on AD, you need a much bigger change in taxes than a change in government spending. Correct? The last multiplier that we studied was the investment spending multiplier. Summarizing this for you. The investment spending multiplier, and this is not something that's part of fiscal policy, not conventionally, because investment spending rises not because the government changes its taxes well, actually, I suppose it could, indirectly, because when the government cuts, say, taxes on businesses, businesses may be left with more of their revenues to go buying new machines with. So in that sense, yes, fiscal policy could affect investment spending. But the more obvious connection is one between the interest rate and investment spending. You see, this would be the Fed, meaning the Federal Reserve Bank's monetary policy. So if the Fed, again, we haven't discussed monetary policy yet, but the idea here is that the Fed controls interest rates. And if the Fed causes interest rates to fall, this would cause investment spending to rise. Why is that? Somebody? Because businesses also borrow money often to buy machines with. And if the interest rate were lowered, businesses are more likely to borrow money cheaply with which to buy machines, right? So what's the investment spending multiplier equal to? Does anyone recall? It has exactly the same value as the government spending multiplier. Now, did we discuss this in class last time? We did, right? Because when firms increase their purchase of new machines by $1, the effect is as if the government increased its spending by $1. The effect will be exactly the same. Because when businesses spend an extra dollar on machines, that extra dollar will, of course, directly affect AD, because investment spending is a part of AD. So that's the direct effect. What's the indirect effect? The dollar will go into the pockets of the factory workers who make machines, and they will then increase their purchase of bread from the baker of $0.9. And the baker will then buy meat from the butcher equal to $0.81, which is 9 square, 0.9 square, etc. So you have the same converging geometric series to infinity that you had with the increase in government spending. And so when you sum up this series to infinity, you arrive at exactly 1 divided by 1 minus the MPC. Right? So the investment spending multiplier and the government spending multiplier have the same value. And how would you define the investment spending multiplier again? That's the change in AD that would result from a $1 increase in investment spending. So here are the three multipliers we've laid out in class, correct? Now you'll notice, if you've been reading the chapter, you will notice that my discussion here has been quite different from the discussion in the chapter, right? So I'm now going to attempt to reconcile these two. I find this to be a more intuitive, an easier explanation than the one that's in the chapter. But I am now going to discuss in this class how your book deals with multipliers, okay? All right, so now we're going to discuss the whole multiplier idea, which you already know now, right? But we're going to arrive at the same multipliers slightly differently, okay? And we start by defining something called planned aggregate expenditure. Planned aggregate expenditure. This is what the four shoppers in our economy plan to spend. Who are the four shoppers in our economy? Households, the government, firms, and the rest of the world, right? So planned aggregate expenditure is what these four plan to spend together. So what would that be equal to then? This is, of course, equal to what households plan to spend. And what do we call that? What do we call that? C, of course, consumption spending, right? Now, what do firms plan to spend? Firms plan to spend something called I, right? But here we're going to make this little change. Something new will be introduced now. I'm going to put a little sub P there to indicate that that is the planned portion of investment spending. Why? Because as I will shortly tell you, investment spending may well have an unplanned component. I'll discuss that in a minute. So since I'm talking about what the four plan to spend, I'm only going to count here the planned portion of investment spending, not the unplanned portion. Okay? What about government spending? Government spending is entirely planned. All that the government spends, it wishes to spend. It was planned. Just as what consumers spend is what they wish to spend. So there's nothing unplanned about consumption spending or government spending, right? And then, of course, we would have net exports. But to keep things simple, I'm going to assume for simplicity that there is no rest of the world. So there is no X minus M in our story. This is just a simplification. Now, I just said that investment spending has two parts. You have the planned portion, and you have the unplanned portion. Now, let me talk about this for a second. What's the unplanned portion? Now, when I have spoken about investment spending in this class, I have mentioned, almost always mentioned, that this is firms' purchases of new machines. Is that correct? Right? However, I may have mentioned this in the past in fleeting, but I'm now going to emphasize this particular point, and that is that changes in firms' stocks of inventories, or inventories as you say it, is also considered investment spending. Have I mentioned this in class before? Right. If I haven't, let me mention this. So it's firms purchase new machines plus changes in the value of firms' stocks of inventories or inventories. Now, what exactly is inventories? Somebody? What does that mean, the word inventory? It basically means goods that haven't yet been sold, that are lying in the firm's stockroom or warehouse. Is that correct? Now, why is that considered part of investment spending? Well, let's say that a firm anticipates selling more of the good it produces during Christmas. At Christmas time, it expects to sell a lot of this good. What would the firm start to do already, even by summer? It would start to put goods away in its stockroom. Am I correct? It would start to pile up inventories because it knows that in Christmas or during Christmas time, there'll be lots of customers for this item. Do you follow what I'm saying? Now, this increase in the firm's stock of inventories is considered to be a kind of investment spending. Why? What's similar between the firm putting goods away into its warehouse and the firm buying new machines? Is there anything similar between these two things? The similarity is that when a firm buys a new machine, it's buying the machine in order to do what? To produce and sell more in the future. And when the firm puts goods away into its warehouse, what is its objective? What is its motivation? Exactly the same. To sell more in the future. Is that right? So whether the firm's buying a machine in order to produce and sell more in the future, or the firm's putting away goods into its stockroom or warehouse in order to sell more in the future, the idea is the same, the objective is the same. Am I correct? And that might be considered the logic for considering changes in firm stocks of inventories to be a kind of investment spending. Okay? So in my example here, the firm expects to sell more at Christmas time, and so it increases its stocks of inventories already. Would you call this planned or unplanned? Planned or unplanned? Planned, correct? So this is an increase in firms' stocks of inventories in a planned way. So this would be part of this. I plan. So what does I plan consist of? Purchase of new machines, because that can't be unplanned. That is always something that is deliberate and planned. So there's nothing unplanned about purchase of new machines. But we would also to this add planned changes in firms' stocks of inventories or inventories. Yes? And now we come to the unplanned part of investment spending. Now, sometimes a firm produces a certain quantity of goods expecting to sell it, but in the end finds that it hasn't been able to sell all of it. Now, that happens all the time. Right? It's because the firm's production decisions based in large part on guesswork. It expects to sell a certain quantity, but in the end it may find that it hasn't managed to sell all of it. So let's say you have a company that makes sneakers, and this sneaker manufacturer has produced 1 million pairs of sneakers, expecting to sell all those pairs, but in the end finds that it has managed to sell only 950,000 pairs. Am I correct? In other words, 50,000 pairs have gone unsold. What will the firm do with these unsold sneakers? Well, it will go into the firm's stockroom, won't it? It will go into the firm's warehouse, am I correct? But would you call this planned? No, this was unplanned, am I correct? Now, this is an increase in the firm's investment spending, but it is an involuntary increase. It's not something that the firm planned on doing. So unplanned investment spending would be unplanned changes in stocks of inventories. Yes? So we've defined planned aggregate expenditure. Now, We are going to introduce another term now, which is called equilibrium aggregate expenditure. What is meant by equilibrium aggregate expenditure? This is when Y is equal to planned aggregate expenditure. Let me explain this. Let me explain this to you. Equilibrium aggregate expenditure. Now, we know that GDP by the expenditure approach. I'd like you to recall what GDP by the expenditure approach was. What was GDP by the expenditure approach? Y was equal to C plus I plus G plus X minus M. Is that correct? Of course, in our story here, we don't have X minus M because there is no rest of the world, right? So Y is equal to C plus I plus G. Am I correct? So equilibrium planned expenditure is when the output of the economy is equal to what the three, I say three now because there is no rest of the world in our story, what the three plan to spend. So that's when we have equilibrium. Am I correct? When the output of the economy is exactly equal to what the three plan to spend. Agreed? So this is our condition for equilibrium now. And keep this in mind as I go to the next, my next slide, next page, okay? So once again, let's go back to planned aggregate expenditure. And what does it consist of? C plus I sub P plus G, correct? Now, let's talk about C. I have already introduced to you the term consumption function, right? Now, what's the consumption function again? The consumption function is a relationship between consumption spending and the income of households. And what is our measure of the income of households? If I take everyone's income in the economy and add it up, what would I get? Wouldn't I simply get this? Right? Why would I get that? Because remember, our circular flow of income idea. Y is GDP, meaning the output of the economy, but the output of the economy is also equal to the income of households, isn't it? Right? If firms produce a certain value of goods and sell it, the money that comes into the cash registers of firms goes back into the pockets of households as factor payments. Rents, interest, wages, etc. Correct? So the consumption function is a relationship between C and Y. What is that relationship? I've mentioned this before. It's C is equal to C0 plus B times Y. Now, let me quickly remind you what this is. I've mentioned this before, by the way. What is C sub 0 called? Autonomous consumption spend. This is the part of consumption spending that is autonomous, meaning independent of household income. Household income being Y, of course, right? So Y is output, but it is also the income of households, and we know this from what? We know this from the idea of the circular flow of income. Right? So this is our consumption function. Now, what is B? The slope of this function. Does anyone recall what that is? Now, firstly, when you have an equation for a straight line like that, you ought to be able to interpret slope. If you have an equation for a straight line like y is equal to mx plus b, what do these things mean? The b and the m in particular. Yes, but sure, but can you give it to me more intuitively? What is m? It is rise over run, but couldn't you think of that as the change in y from a 1 unit change in x? Isn't that what the slope is? And what does the intercept mean? The intercept would be value of y when x is 0. That's how you interpret the intercept and the slope of a straight line. Correct? So in terms of this equation here, which is also, by the way, the equation for a straight line, c is equal to c sub 0 plus b times y. That is in the form y equals mx plus b, isn't it? So what's the slope? The slope is, so this is our intercept. And what's the slope? The slope, of course, is that b there. And what is b then? Change in c from a 1 unit change in y. Now you know what that is. Come on, tell me. Scratch your heads a little and tell me what that is. Change in consumption spending from a $1 increase in your income. What is that called? Ring a bell? The MPC, of course. Isn't that what the MPC is? What's an MPC of 0.9 mean? What does the MPC of 0.9 mean, somebody? Now, doesn't that mean that when income goes up by $1, people increase their consumption spending by 90 cents? Isn't that the meaning of that 0.9? Therefore, when the workers working on the Hoover Dam got paid an extra $1 of income, they bought how much extra bread from the baker? 90 cents. Is that right? So that B there is nothing but the MPC then. So this is our consumption function. Right? So I am now going to write planned AE as follows. So I'm now doing it the way your book's doing it, okay? But in the end, I'll arrive at exactly the same multipliers as I've already, derived. Planned AE is going to be then C0 plus B times Y. This, of course, is the C part of it. I'm replacing C by the function for C. Plus IP plus G. That's planned aggregate expenditure. Right? So now let's talk about equilibrium. So when do we have equilibrium again, as discussed in the previous slide? We have equilibrium when Y is equal to planned aggregate expenditure. Right? So I'm going to use that same condition in this slide. So we have Y is equal to planned aggregate expenditure. And what is planned aggregate expenditure? C0 plus BY plus IP plus G. Yes? Now that may look confusing, but really it isn't. All we're doing is we're just writing something is equal to something in terms of these symbols. That's all. Don't let the symbols phase you. Right? Now in this condition here for equilibrium that I've just put down, there are numbers there that are known to the economist, and there are some unknowns. What are the numbers that are known to the economist? This is, for instance, a number. Government spending. It's something that's known. Investment spending, the planned portion of that is also something it's a number. It's a dollar figure. Am I correct? C sub 0. C sub 0 is also a number known to the economist. What about this B? Well, the B is a number known to the economist also. Correct? The one unknown here is the Y. And that particular Y that solves for this equation shall be called equilibrium Y. So what is equilibrium Y? Or let's call it Y star. It's that Y for which that condition for equilibrium holds. Right? So let's solve for that Y then. Yes? So what are we trying to do here again? We have this condition for equilibrium, which is to say that what the three shoppers plan to buy is exactly what the economy, in a sense, produces. Right? And this is not going to be true for any Y, because you must remember that this is the output of the economy, but it is also the income of households. So let's say the economy produces a certain level of output, which is also income. Where does that income go? That income goes here. That income determines consumption spending. So you have output. The output determines consumption spending, and the consumption spending determines planned AE. Do you see? So you are not guaranteed that this shall equal this. This is not guaranteed. This is only going to be true for a particular value of Y. It's not going to be true for all Y's. Okay, that's what I'm trying to get at here. So let us now focus again on this last equation that I have put down here. So what is that condition for equilibrium again? The output of the economy is equal to what the three plan to buy. C0 plus B times Y plus IP plus G. Right? And let us now solve for Y. In other words, let us find the particular value of Y for which this condition holds true, because this condition is not going to hold true for any old Y. It is only going to hold true for a specific Y, which is the Y we are now going to try to calculate. So how do we calculate this unknown Y? This is an equation in one unknown. How do we solve for that unknown? Do we know how to do this? We would, of course, have to first gather all the Y's to one side of the equation. Correct? Right? So to gather all the Y's to one side of the equation, I am going to have to subtract by from both sides. Because that way I get rid of this by and that by. Correct? Yes? Okay, next. What do I have now? I have y minus by is equal to C0 plus IP plus G. And remember, these are all numbers. I haven't put them here as numbers, but they are numbers. They're all dollar figures. Correct? Now what do we do to solve for the y? Well, this y can be thought of as 1 times y, right? So you have 1 times y minus b times y. We can factor out the y. So we can take y outside of brackets and write 1 minus b, can't we? Would that be right? Correct? And that's equal to C0 plus IP plus G. Yes? Finally, what do we do to solve for that unknown y? Somebody? We would divide through by what? Correct? Right? Because when we do that, this and this cancel out. Yes? So in the end, we are left with y is equal to this stuff here, but I'm now going to write that y as y star. I'm going to write that as y star y, because that is the y that, or for which this condition holds true. This is the y for which this condition holds true. The condition for equilibrium. That's the only y for which that condition holds true. So that is equilibrium y then. So equilibrium y is equal to C0 plus IP plus G divided by 1 minus B. Yes? Okay, now we are in a position to discuss the effect of a $1 change in government spending. Right? So let's say that we raise government spending by $1. What will be the effect on Y star? This question. Now, what is Y star? Y star is when Y is equal to planned aggregate expenditure. So this would be considered to be equilibrium planned AE. Is that correct? It's equilibrium planned AE, because that's the level of planned expenditure that equals the output of the economy. Right? So what's going to happen to equilibrium planned expenditure if G goes up by 1? Well, this is how we can do it. We have a new equilibrium planned expenditure Y double star, and that shall equal to C0 plus IP plus the old G plus 1 divided by 1 minus B. So what have we done here? All we've done is raise the G by 1. Yes? Could I now ask you to calculate the difference between Y double star and Y star? In other words, by how much has equilibrium planned expenditure or equilibrium planned aggregate expenditure changed because of that $1 increase in government spending? Well, what is Y double star? That's C0 plus IP plus G plus 1 divided by 1 minus B. And what's Y star? C0 plus IP plus the old G divided by 1 minus B. Agreed? Now, quite a bit of algebra there on the board, but shouldn't be beyond you, I don't think. If you've not understood me, please raise your hand and I will go through this again quickly. Do you see what's happening here? So what am I doing here again? The first thing I did, of course, was I derived Y star. And I had this equation for Y star. And what again is Y star? It's the level of planned aggregate expenditure that is the equilibrium planned aggregate expenditure. Is that correct? Right? And then what I did was I jogged G. I changed G by how much? I raised it by a buck. And when I raise it by a buck, I get a whole new value for Y star. I'm going to call it Y double star, which is right there in blue. Y double star is equal to C0 plus IP plus the old G plus 1 divided by 1 minus B. Agreed? Right? Lastly, what I try to do is I try to find the difference between Y double star and Y star. I'm trying to figure out the increase in planned aggregate expenditure, or rather the increase in equilibrium planned aggregate expenditure because of that $1 increase in G. Could we now do this last bit here? You notice here that both these fractions have the same denominator, so of course we can simply write that as a common denominator, right? And then we can write everything down. Yes? Now, what is it going to be? Tell me. C0 plus IP plus G plus 1 minus C0 plus IP plus G. Is that correct? Now, if I get rid of the brackets there, what would I get? One minus B is the denominator. And then I'm going to get rid of those brackets. So I have C0 plus IP plus G plus 1. And then get rid of those brackets again. What am I going to get? Now remember, there's a minus sign in front of those brackets. That's significant. So when I remove those brackets, what will I get? Minus C0 minus IP minus G. Is that right? Now let's do some cancelling. Plus C0 here, minus C0 there. Plus IP here, minus IP there. Right? Plus G here, minus G there. Right? So what are we left with in the end? Let me tell you. What am I left with in the end? 1 divided by 1 minus B. Does that look familiar to you? What's 1 divided by 1 minus B? What's B? B is the MPC, isn't it? So isn't that nothing but 1 divided by 1 minus the MPC? And we know that to be what again? The government spending multiplier. Right? So what is the government spending multiplier again? It's the change in equilibrium planned aggregate expenditure when government spending rises by $1. Is that correct? So what is this again? This is equal to change in equilibrium planned aggregate expenditure when government spending rises by $1. Right? Now, previously, when we previously defined the government spending multiplier, how did we define it? What's the government spending multiplier defined as? The change in AD. That would result from a $1 increase in G. The only difference now is that instead of saying AD, we are saying planned, or rather equilibrium planned aggregate expenditure. But really, they're the same thing. Right? What we called AD before, we're now calling equilibrium planned aggregate expenditure. Right? So we derive, how do we derive this, by the way? We derive this by doing what? By adding up a geometric series to infinity. Is that correct? Right? How do we derive the multiplier now? How do we derive this? We derive this differently. Am I correct? We derive this by a different route, but we, in the end, got the same answer. This is how your book does it. Do you follow me? I thought I would show you how to do this the alternative way, but in the end, you arrive at pretty much the same multiplier. Correct? Now, let's quickly look at the investment spending multiplier. Okay? So how would that work, the investment spending multiplier? Now, again, I am going to go to my condition, my equation for equilibrium planned aggregate expenditure. And what is that? Y star is equal to C0 plus IP plus G, right? Divided by 1 minus B, right? But now let me do this. Let's say the Fed lowers interest rates so as to cause planned investment spending to go up by $1. Right? Now, if I cause that to go up by $1, I end up with a whole new level of planned aggregate expenditure, or equilibrium planned aggregate expenditure. And that is going to be what? C0 plus IP plus 1 plus G divided by 1 minus B. Right? So what is the change in equilibrium planned aggregate expenditure? It would be Y double star minus Y star. And you would do it in the same way that we did it in the previous slide. And you know, it'll be exactly the same. The only difference will be that instead of putting the plus 1 here, we'll be putting the plus 1 here. Do you see that? So in the end, we end up with exactly the same 1 divided by 1 minus B. So in the end, we would end up with, again, 1 divided by 1 minus B, which is 1 divided by 1 minus the MPC. And isn't that the value of the investment spending multiplier as derived in the other way? Yes? So this is how you can get the investment spending multiplier using this alternative method. And now for the tax multiplier. Okay. Now once again, I'm going to write down the consumption function. C is equal to C0 plus B times, but now I'm not going to say Y. I'm going to say Y sub D. Now what is Y sub D? Y sub D is disposable income. It's the income of households that it has left after paying taxes. So it would be Y minus taxes, where T is taxes. Right? What households spend depends on what they have left over. Depends upon the income that they have left over after paying taxes. Right? So if I write this out, I get is equal to C0 plus B times Y minus taxes. So that's my new consumption function. Right? So in that case, what is planned aggregate expenditure? Planned aggregate expenditure would be this, which is C plus IP plus G. Right? Now once again, condition for equilibrium. Condition for equilibrium is that Y is equal to planned aggregate expenditure. And we can write this now as C0 plus B times Y minus T plus IP plus G. Right? Let's open up this bracket here. We get C0 plus BY minus BT plus IP plus G. Are you all with me here? Take some time to catch up if you're copying this down. Right? Now we have to solve for the Y. And how do we solve for the Y? By collecting the Y terms on one side, as we previously did. And to do that, we basically subtract BY from both sides. This gets rid of this and this. So we are left with Y minus BY is equal to C0 minus B times taxes plus IP plus G. Factor out the Y here as before. Let me give you a second to catch up if you're taking notes. Last step remains to solve for that Y, that equilibrium planned aggregate expenditure. And to do that, we divide through by 1 minus B as we did before. Cancel, cancel. And so we have our equation. Y star is equal to C0 minus B times taxes plus IB plus G divided by 1 minus B. Agreed? Now that's a bit different from what we had before. What's different about it? I'm sorry, I lost track of time today. Well, we will carry on next class. This is where we were, okay? Keep this in mind. Stop here today.